This video will give an overview of the workflow to determine speed of vehicles, integrating point cloud data with CCTV imagery using both Map360 and Input-Ace. It's going to be a step-by-step workflow. So the first step is to open the video, adjust to the correct aspect ratio. We can integrate the video file using Input-Ace to figure this out. And from here, we'll take a screenshot to understand then what's the center of this image. So we do something like this, for example, and then using a image editor of sorts, you will estimate what would be the center of the image, which will intersect in that position over there. From there, we go into Map360 and we'll insert a camera on the position on where the CCTV is, the CCTV camera is. So I can show you here real close with the RTC data that there's a CCTV camera in that location over there. And I also create a point here. That X marks the spot where the image on the CCTV intersects the center of the image. From here, we'll tweak the camera position so that it matches as best as possible the CCTV image, like so, and we'll screenshot this view as it is here as well. From here, we'll open Input-Ace and we'll load up the screenshot of the point cloud in Map360 and also the original video file. Step 1 is in loading data. Step 2 is to correct lens distortions, where the software takes us to a step of creating lines which appear distorted on the CCTV imagery, which then Input-Ace will remove the distortion. Third step will be to pick common points between the imagery and the point cloud data so that then it matches them and becomes metric. Now that the image is flattened out, you can proceed to do this step. After that step is completed, there's a process of quality and controlling the data. But you can see here the software then matches with a crop overlay with this from the CCTV with the available area to match it in Map360, the point cloud data. Finally, I don't need to save this file because I've saved it previously. Finally, we can process the camera matching and we can launch our overlay tool, for which we'll pick up the file which was previously generated. And all we have to do now is line up this image frame with the view in Map360, which will, not surprisingly, match the area on where the screenshot was taken. But this can be adjusted even pixel by pixel if I wanted to. So if I go here on 150, you can see that the image moved 5 pixels up. How much you actually wanted to move it? 5 pixels down. Sorry. And we can adjust this until it's correctly lined up. Like so. At this stage, we can then lock the view. So everything that I do now, I'm not moving the image, I'm working directly into Map360. So case in point, if I was to take a distance, remove the opacity a bit. If I want to understand this distance, I will just need to click on the image and it will tell me what the distance is. Okay, like so. Which means then if I move my vehicles by each individual frame, I can then start creating points and lines to line up the front and the rear wheel track. So I can create a point position over there, and I can create another point position over here, and then I can move the vehicle a few frames up, and I'll do the same. And obviously, because now I have the points in Map360, it's very simple to then determine the distance from them, and by understanding the frame rate of the video feed, which is a whole subject in itself, we can then determine the speed of the vehicle. Okay, that's it. Hope you like it.